Okay, YouTube, back again already. I don't even think it's been 10 minutes. This is going to be the second video for today. Yesterday was simply just, or sorry, not yesterday, just a few minutes ago, was simply just a follow-up video for the Xbox One X that was previously repaired, a separate board from this one. In that repair, we dealt with issues regarding board curvature and warping that potentially were disrupting the ability to maintain system function in order to perform a restore, in addition to having some hard drive challenges that ended up resulting in replacement of the hard drive to fully correct that due to head stuck on the platter. Now this one came to me by way of another shop that does repairs. However, they do not replace the HDMI, so they send that work to me. Now, for the Xbox One X, there is currently no supply, at least that I know of, for the HDMI ports. So, unless we had a donor board to pull from, which we don't, this customer has opted to have their HDMI in port pulled, removed, and then replaced with their out. And that out is going to be thrown in the trash because it is damaged beyond any use. And so this customer from here on out will now have a missing port, at least until some supply becomes available, and if they decide that they want to pay to have that reinstalled. But the general consensus from that client was that they do not use that feature and never intend to. So really no benefit to have that done. But great that it was there, as that allows us to have a swap out part without having to pay the ridiculous price that was listed on eBay of a $100, $99.99 for this little guy. No, I'm not going to do it. Client didn't want to do it, and if you do it, sure, why not? It's your money. Okay, so first step here, and I did this in our last video, but then I went and jacked it up because I had some other stuff to look at, or I wanted to change the viewing angle. But we are going to do our parfocling, which means we need to... no wonder the view for you is not changing. And I'm watching my video stream and I'm seeing something irregular. It looked like we had a freeze. It almost looks like our video stream is not very good quality, but maybe that's just... maybe it's me, but let me close out some of these windows. Our CPU looks good. I don't know if maybe something's going on with bandwidth or if it's just whatever, but man, that looks rugged. I'm seeing somebody now is saying something about the quality of the video. So I am checking the video quality. So we got someone from Brazil. It's Rafa Batuta. Did I say that right? Alright, so I'm changing the latency. Let's see if it will. I've never had an issue where the video quality wasn't on par. Okay, it looks like video quality just got better. So it looked like it needed to have a latency change. So I will keep that setting for now. Alright, so I'm waving my hand in, trying to see what our latency looks like so I can keep a track on it. And it's not that bad. It's about 10 seconds behind. So that's a decent latency. I should notice any issues that appear without them going on for too long. All right, so what we're going to do now is we're going to switch to include our microscope. And let's actually make the scope our bigger focus point. And we're going to go back to doing the parfocaling, which is where we're going to zoom in tight. And we're going to lose our image, but that's okay. That's what we want to happen. And we're going to bring it into focus. Once we find that sweet spot, now we can back it up. And now we're going to adjust our eyepieces to give us the best focus we can get at this setting. Once both eyepieces are adjusted, that is giving us, and I know it's blurry for you, but that's okay, this is a trinocular. So we've got a third caveat to that, which is now adjusting the trinocular. So that is how, again, you do parfocaling. It's a 3-step process if you have a trinocular, a 2-step process if you don't. And like I said, you do your zoom all the way in, which now I can do that without you losing. It might be a little blurry for you guys. Let's see if we can tighten this up. Alright, so I made a little bit of an adjustment. And we'll make another one. Alright, so again, parfocaling, you're going to zoom all the way in, and then you adjust the height of your camera up and down. I'm not sure if you can see that in the little, see how I'm going up and down in the little window? And then again, I'm going to have to now reset this. We're going to adjust it back to where it's good, and that's right there. And then now we can zoom out. And although this part doesn't affect you, if you're the one using the camera, you will now need to adjust your eyepieces so that when you look through the eye holes, you're seeing the best focus and clarity possible. And the easiest way to do that is to spin it in both directions to see where it starts to get out of focus, and then adjust to where you feel is the best natural focus for your eyesight. So everyone's going to be a little bit different because all of our eyesights are a little bit different. I'm wearing glasses myself, so I don't have perfect 20/20, but even still, each eye is a little bit different, each person is a little bit different. Alright, so now that that's done, we can go back to look at the actual HDMI port. And again, we're going to be taking both of these off. So what we'll do now is we're actually going to turn this a little bit. And let's go ahead and we'll one by one these. And I'm going to give this a bit of a tilt so that it's better viewed in your camera view. Finding something that'll give us the best height here. Improvised kickstand, so to speak. And I'm going to slide back over for, excellent. Thanks for the subscribe. I slid back over so that I could see my chat window. Alright, so now that this view is tilted so that you can see what's going on, we're going to go ahead and turn on the soldering iron. I'm going to put on some gloves because we always want to wear those while working with flux. And we're going to apply a little bit of flux to our board on the area that we're working in. And again, what we're going to do is try to wet these joints, get some good, easy to use solder on them versus what the manufacturers use, basically switching over to a lead-free and just getting something that's fresh and hasn't been dried out through whatever profile they put it through. And I am using the new Pace ADS 200 AccuDrive, if anyone's curious. I've done a couple of videos on this one. I'm so far liking this soldering iron. It wasn't sent to me, as I'm sure anyone can tell. I don't have enough people watching my stream for anyone to care to send me good stuff. So all my equipment I've bought, I've paid for. And you're going to get my opinion, for better or worse, of what I think that machine is like. And I now need to see where I stuffed the flux. Up, right in front of my face, off to the right. Alright, so we're just going to put a little bit, not a lot. You want to get it on the port, on the legs. Oops. And you can see you don't have to be special with it. You don't have to be tender with it. And we're going to go ahead and hit this back one too. We're going to go ahead and get that one in there so that we don't have to pick it up separate when I switch over to it. Oh, look at that. There's a little gob of solder inside that needle. And we're also going to add some solder. And as always, I like to use keister solder. You can use whatever you like, unless what you like is the cheap stuff from China, then I recommend you throw that garbage in the trash. I used to use that all the time myself until one day I realized that it was part of the problem. It makes joints that look like turds versus shiny, nice. I mean, look at that. You can already see just the edge of that. And lead-free is always going to be a little bit duller than leaded. But I would get leaded solder with, I forget now what the infamous name is that everybody gets. But this stuff just never made nice joints and would easily become brittle and crack. And all we want to do is just get a nice bit of solder down in here to make sure that it's going to flow and transfer that heat as efficiently as possible. And this is our second one because remember, again, we're pulling one and swapping it out with the other. Now this is our defective one. I know that from location, as well as it's the one with the retimer directly connected. A little strand of solder tried to slide up through the side. And we're just going to go ahead and let all that soak in. Now, I think it was in the start of my previous video, but I do have the air extraction turned on. Sometimes I forget to do it. I realize it usually about halfway through because I'm starting to cough from any fumes that are being pushed out. And for me, this is not about speed. It's more about making it easier. And here, we're going to get to see the actual damage. Well, at least some of it. So this split right here, this is actually caused by improperly removing your HDMI. They're pulling it, and they're pulling from an angle which causes it to exit sideways. And when you pull your HDMI out sideways, you break this tension here, and you end up breaking the internal pin structure. And at that point, you're no longer going to work the way that it was intended. So if you're not pulling your HDMI ports straight out and putting them straight in, you're going to cause yourself a problem, and you're going to end up being on my table or someone else's that does similar repairs. And a little solder ball flew off and away and landed actually on a chip. Usually those go flying off and never hit anything. So now you don't have to do it this way where you're kind of pre-tinning everything, but I just like to do it because it allows us to use less heat in that reflow process of removing these. And in my opinion, you want to use as little of that as possible. And then we're going to clean up this ball that ran away on us. And as simple as that. Now we're moving over to the other one. I want to make sure that I am in camera angle. I am. And we're going to get some fresh solder to apply. So this is all about prep work right now. All we're doing is just prepping this for the hot air gun. And you know, if you wanted to, you could skip this. You could just go straight to hot air, let it melt, let it come out. It probably wouldn't make a difference, but because replacing these HDMIs is going to cost me $100, I want to make sure I get it right the first time. I don't want to have to buy one or have to tell the customer, I'm sorry, your HDMI just didn't want to come off, and you're going to have to wait until a viable replacement is available. Come on now. And in fact, what we can do is we can go ahead and use a little hot air, but we're going to use a low level just to help kind of get some of this down there. And this is where, even though this is a good soldering iron, I mean, I don't have the heat all the way up, and this is a huge ground plane, so who knows, maybe it's just normal, but I need to get my Metcal back up and running so that I can do a comparison. So I'm pretty sure that sucker, even at 370, would push, without the help of hot air, that solder all the way through these joints. But see, this is the good port, and it's being this resistant to solder. And I could go up in temp on this iron, but I shouldn't need to. I mean, the other one took it at this temp, even without the hot air. And sometimes they're just like that. It has to do with the solder in it, how dried out it's become, and whether or not it's allowing it to kind of transfer heat as efficiently as it should, or if it's been kind of dry rotted, is a term we use in the industry, where it makes it less effective at accepting heat. And that's where flux comes in, not to mention while applying heat. So it does two things. It removes oxidization and prevents oxidation from allowing to occur, as well as it lowers the melting temperature of the solder in use. So there's those two things going on for it to kind of help you as you're doing this work. But even with all that, it doesn't always work as expected. And that's when you have to adjust your profile, turn up your heat, add some hot air, basically get a little creative. But because the internals of this HDMI port are plastic, we don't want to get so crazy with hot air that we cause them to distort. That's why I'm using a rather small tip at this point where I can control that airflow and I can point it where I want it without allowing it to run wild. So that's taking solder well. You know what, I wonder, this is the second one. I wonder if we didn't do the top side all the way in. I just did the edges. I bet you that is a possibility. Nope, it's not a possibility. I did do. Alright. Like I said, we don't want to run a risk with this, so I'm making sure that I take my time. And let all this solder kind of flow through on that joint. And you get to a point where you know what it should look like. And you can see a joint that's going to be problematic versus one that looks like it's just ready to let everything kind of pop out. And I think we've got this about as good as it's going to get. We're going to go ahead and we're going to turn these over. And I've popped my tip off. Not sure if you can see that. Yeah, right there in the small window. I no longer have that controlled tip on there. And we're going to heat this up. And again, I have it on this prop. And now our angle has changed, but it hasn't really for you in the video. So, well, this will actually give us a better view. All right, so right now I'm just starting with low heat. We're going to prep this whole area. We heated it up, but we did so in kind of small, isolated areas. Right now I'm actually heating up both of these ports, and I'm only using 175 degrees heat. And I'm going to put my finger to the board, and it's going to get hot, hotter than probably most people would like to stand. Eventually, you build up a tolerance to it. But I'm feeling for when I feel like this board has reached a nice kind of neutral temp, because we don't want to shock the board. And now we're going to kick it up a little bit in temp. We're sitting now at about 350, and I've got airflow cranked all the way up. Now the board is very hot to the touch. You can't keep your finger on it almost at all. And we just want these to kind of pop out on their own. We don't want to force them. And we're going to go up to, basically we're going to max out our temp and our airflow. And we're going to move a little bit faster in that left to right motion. And my tweezers weren't as handy as this little flathead was, so I just grabbed it. And you can see now that solder is moving on its own. It's kind of the first sign of it being almost ready to give. But again, we're giving just very gentle pressure. We don't want to force this out, otherwise we'll have more problems. Okay, now this is a little different. I'm not sure what. Okay, it's starting to give there. And over here is where we're getting some resistance. Okay, that's starting to give now. Alright, we got it moving. And look at that wiggle. Alright, so we just kind of kick that under. Now this one, we can be a less gentle with it, but we don't want to damage the board. We don't want to damage the contact pads. But this is our broken one. So we don't have to worry about overheating and overstressing this. And look at that, it's already loose because that heat that's been transferring to it while we were mostly focused on that other side. All right. So now that that is done, let's come back and we'll look at our port and make sure that it's viable for use. Now we've got to adjust this because remember I moved it before. All right. So now we've got all this solder built up on it, but this is an easy fix. We're going to take our soldering iron and we could probably just drag this off. Alright, so we are going to use a little bit of wick. We're going to go ahead and pre-apply some flux to this wick just to make life easy. Ooh, hot, hot, hot. A wick will get hot quick. Let's clean that up a little. There we go. And we're actually just going to go ahead and cut this away. Let's take another look at this. Should we remove more? I don't think it's necessary. Although, you know what? It will make it easier to insert. Let's go ahead. We're going to clean this up all the way. Alright, so what we want to do is come on now. This is a very awkward angle to hold it at. Alright, so we're going to try this backwards. Ooh, it's hot. So hot. Where are my tweezers at? And we need some more flux. Alright, that actually got pretty clean right there. Let's see. It's sticking to my glove. Alright, I think that's as good as we can get it. I'm not sure how much of that was in video. I'll try to do better. But and I'm readjusting here. I'm trying to get you guys in the best focus. There we go. Alright, so you can see now that's been cleaned. These legs cleaned off, because if we have too much of kind of like a bulbous solder joint on those legs, it won't slide into the slots that we need to get these to go through. Now we also need to evacuate the solder from, and we only need to do it from the one. Let's take a look. We need to get the solder out of this one here. So what we're going to do is we're going to use the same one. We're not going to cut it off yet, because sometimes you need that little start of solder on your wick in order to get kind of a good thermal transfer that will allow you to suck up what's down in there. And then let me go back to adding just a little bit of heat. It's a pretty low temp. I've got it set at 175. It could be higher, but again, keeping it low just to not overboard anything. Alright, we're definitely not hot enough. I'm going to go ahead and try cranking the iron up. We're going to bring it up to about 420, and that is Celsius. And oops, we are going to cut away some of this. This will work so much better. And again, I'm trying to use low heat. Normally I would crank up this air to a hotter temp, but I want to see what the tolerance is to get this out. Alright, and that's not going to do it. So we're going to go up now to 350, using a medium airflow. I really don't want to and don't think that I should have to go up to 450, but I mean that's normally what I use on the PlayStation, but I want to try this out with a couple of different temps. Just kind of exploring and seeing what works better. Now it looks like 350 gets it done. It's just having fresh strip of wick or a desolder braid, whatever you like to call it, having the temp up at around 420 Celsius is what I'm using right now, and that 350 on the heat, and that did it. Okay, so I would say that would probably be my future setting, is I'm going to use 350 on hot air, I'm going to use 420 on the iron. We can turn that iron back down now. And now what we're going to do is we're going to clean this up. See how this looks a little dirty? That's what we want to get rid of. We don't want to use that when we're applying our, well, not our new HDMI port, but our functional HDMI port. We don't want to have that sticky brown gook. And look how, I mean, look how dirty that is. That's what we want to get rid of. Because all that's going to do is get flowed back into those joints, and the more oxidization and debris and everything else they have, the less thermally conductive and reactive to the flux that they will be. Now I actually see on my other one that we're going to leave blank, I have a bridged line, and that's okay. We're going to fix that before we're done, but you definitely need to make sure that you didn't leave any bridges on your HDMI in. That can cause you issues. And what we'll probably actually do is apply tape to this area after we're done with it, just so that it can't get anything on it. So now that it's been properly cleaned, we're going to go ahead and apply flux. I like to get flux in all the holes. Well, it doesn't need to be in the hole that's not going to get soldered. That's just me being silly. You don't need to go crazy with it, but my opinion is there's no such thing as too much. There's no such thing as too little. It's just what works for you. The only thing that too much flux does is gives you a bigger mess to clean up. Now, if you're working on 0402 packages and they're tightly densed like in a cell phone, it could become an issue then, because now you're starting to work with a lot of stuff that's really close together. And it becomes a little bit more delicate, and your airflow, the flux is going to make them where they melt and they can move. I'm just making sure all this lines up, and it does. And see how this fits in nice and easy, and I can, let me make the board stop moving, but I can wiggle that and I can move it. That's why we wanted all that gook off, because if we can't do that, we can't properly align it. A lot of people will say, oh, just reflow it in there, but then the problem is that your HDMI is not centered the way that you want it to be, and that's pivotal in making sure that these work properly, not just in the short term, but in the long term as well. So, I'm going to retin this tip, make that well worked over in the last one. And I'm I'm actually just going to put all this on there. And I'm going to rotate. This is what I like to do. I like to rotate it. It should be freely moving over. And see how it gets all clumpy and nasty? That's what we want to get rid of. So I'm going to get that off. And then I'm going to come back at it again. With more of my solder. And we're almost to where I think we should be. And yeah, I would say that is pretty good. Now, what we're not going to do is we're not going to pre-tin our foot post, these areas, these big ones. We're only going to pre-tin this. And that's all it needs. Just going to kind of give it a little bit of extra solder so that it has something to bond and bite down on that those HDMI port legs. So now what we're going to do is we're going to adjust this board before we mount and start to solder the legs. We're going to get our legs locked in place the way we want them, and then we're going to solder our footing. So again, we have our port. Still fits in those holes. If we had pre-tinned these little solder leg holes, we'd probably run into issues where we wouldn't have the maneuverability that we want. And I used to be one of those that, you know, I would always get it right back on the edge. That's not the way to do this. We want to pull this HDMI port forward as much as possible while still keeping it straight. And then what that allows us to do is have a wicking area. That forward part of the pad becomes where we're actually able to tap and get contact. And then we can do things like just a little bit of drag solder. I'm going to kiss those front ends. In my opinion, it could be a little bit better, but if you get something that flows in on a joint, that's okay. Let's go ahead. We're going to prop this again so you can get that angle down into it. You can actually see where we now have some bridges. But as I said before, that's all right. We're just going to clean those bridges up. We're going to do so by adding just a little bit more flux, and hopefully we won't even need a soldering wick. You'll notice that I like to heat up the tip of that soldering dispenser. To me, it just seems to make it flow a little bit more controlled. I think regardless of what we tried, and normally I wouldn't lock in all these legs. I would only probably go for like a couple on the edges, but it just seemed like it had a good amount of adherence and that it was okay. It doesn't seem to be moving on us, and we'll check it out before we move on. We've still got these last little bits. Like I said, I'm going to try not to use the solder wick, but what I will do, just my own little preferred cheat, I'm not going to use the solder wick on the actual pad because then it may suck away some of what we want. But I'm going to clean off my tip using that solder wick just to kind of dry it out so that it wants to pull all this away. And we're down to just 2 pins now that are bridged. If you try this technique and it doesn't work for you, don't feel bad. It's taken me quite a while to develop my own little way of cleaning out these bridges. Like I said, a lot about soldering is what works for you. You may have a better method, but for me, I've found that this is what works for me. So now all of those bridges, and I think we can actually make this view a little bit sharper. That might be as sharp as I can get it, at least until I upgrade again to a different camera. Alright, so now I'm going to go ahead, since we have all the pins locked in, I'm going to go ahead and give that a quick little cleanup. Notice some of our flux started to get a little brown. If it does start to get like that on yours, before going too far, I would recommend cleaning, because I'm already, now that I've cleaned it, noticed some joint issues that I would like to touch up. Things that you just don't notice if you got a little ball of goop in there kind of obstructing your view. Now, before I lock down the feet here, and there's actually 2 on each side, but before I do that, I want to check and make sure that we're solid, and we are connected all the way through, but these 2 on the very end over here where I'm tapping, those I think can be a little bit better. And I'm also going to check, which you can't really see from this angle, let's see, this one you can see it pretty well. I'm going to check for flushness underneath. There's actually a plastic pad that this sits down on, and we want to make sure that it's flush and even, and we want to make sure that we're also fairly square here. We don't want to be too tilted in one direction or the other. Otherwise, then we're going to run into the problem where once it's seated into its position, it's going to have lineup issues that are going to affect performance. But everything seems to look pretty good, and I think we're at a stage where we can go ahead and say, let's lock it in. Trying to get that angle a little more clear because I keep changing. Once you change the height of your subject, you have to adjust your camera, and that's the biggest problem with making these, is that, and maybe where an autofocus may become necessary, is that you're adjusting your subject quite a bit because you want to work, you want the board to work for you, not you work for the board. That's the best way to put it. If you're having to twist and contort yourself, you're not going to have a good time soldering, and chances are your work is going to show it. So position the board in a method that is comfortable for you. If you are trying to live stream it, then by all means make it work for the camera, but first and foremost, it has to work for you. If you're struggling to contort yourself so that you can get a shot, you're probably not making good video anyway, because whatever you're doing isn't going to come out right, or at least not with huge amounts of effort. And I always say my videos take me a lot longer than this takes me when I'm not streaming, and that's usually because I'm talking through every step, and I'm just trying to have a conversation even though it's only with myself. Once I get a little bit more acquainted with some of the controls of this live stream, I can try to work in other interactive means so that you, the audience, can chime in and participate and kind of ask questions on the fly. Alright, so I flowed the top, and I'll probably end up cleaning up some of this excess, but we're now going to flip it over, and we're going to notice that it's not flowed all the way through. We can start to see where the joints are joining, but they're not coming all the way up. And that's okay, we expect that. We want to add the solder on this side. And this is just my method of doing it. If you have a different way, a better way, whatever that is, by all means go for it. But what I found to be some of the strongest and most reliable joints are following this method. Get it on the top side of the feet, get it on the bottom side of the feet, and then we're going to flip back over to the top, and we're going to join by using some hot air as well as the soldering iron itself. And we're going to make sure that that solder is bonded through the entire solderable or connective surface throughout this entire, this is a through hole, and these through holes have a copper and kind of like a via channel, but this is just for mounting. But this footing is your support. So if you don't make it strong and you don't make it sturdy and you don't ensure that that bond and that heat has gone all the way through so that it's soldered even in the center, not just on these outer edges, you're going to have a weak joint, and it's going to want to pull apart if somebody is very rough with it. And as we all know, most customers are very rough. Even doing this, I've still seen them pull them out and apart. But this at least makes it a little bit harder. And then we're going to add our final touch-up. Oh, we're not in camera. We're going to add our final touch-up at the very end, which should give our last little bit of extra support to make it even more sturdy. Alright, so I've turned the heat back down. We don't want to use 400 on this part because we're now topside. And again, inside of this opening here, we're going to have plastic pieces that will melt and warp and bend. But I'm not sure if you can see from, okay, yeah, you can see once I move it out of the way, that we actually now have the solder is just draining itself into that port. And before we had solder on the end where my tip is, but not on this inside edge. Now we have solder on both sides. And what this actually should be a really good angle because I can show it as it heats up. And watch that interior edge of that back leg. And there, it just got wet and the solder moved internally without actually touching it, at least on this side. So now that is how you know that that solder leg has started to go all the way through. But to make sure, we're going to flip it again. I said, better safe than sorry. Add the extra steps and know that it's done right. Now, with it upside down, we have to be a little bit more careful. We don't want to overheat it because then it'll just want to fall out. We don't want to put pressure from the underside, otherwise we could misalign it while it's liquidous and able to move very freely and very easily. So it's kind of this balancing act of getting everything just right. But if we get this the way it needs to be, the customer should have a good, solid HDMI that'll last them many years to come, as long as they quit doing the reach around when they pull their cable out. Alright, so now that all of that is done, we're going to do the last step. Well, the last step in terms of the footing. So what we want to do is we want to create a solid leg. And this is just my little preference here. I like to think that if you have both legs joined, that when someone goes to pry at it in a way that they shouldn't, which is another common failure that I've seen with PlayStations and Xboxes, these legs here, if they start rocking that port, this gives it where both sides are connected together and makes it a little bit less pliable. So adding that joining there makes a sturdier joint. I'm no mechanical engineer, but at least in my mind, that's how it works. So now that part is complete. We're going to flip it back over and we're going to check out our legs again. And I'm not sure if this is see that second pin there? Just see how it doesn't look like it's all the way soldered like the other ones are? And it is connected. In fact, I can demonstrate. It's not going to move. But for the sake of having a good, sturdy joint, see, neither of these are moving. We want to just tidy that up a bit. And to make this real simple, we're going to change our tip. Let's go ahead and we're going to tin this tip before we put it away. All right. Oh. And I haven't put those tips back where they're supposed to be. We're going to pull out this little guy here. And he has a tiny little solder, but he's going to be great for this little narrow pitch. It's going to allow us to get right up in there. And in fact, we're going to apply a little tweezer here. And we're going to need a little bit of solder. Figure out how I want to grab this. All right, let's just put some on the tip. And we're going to adjust again. And now we've got that joint all the way to the edge, which is what I like to see. I want to see it flowing out and over onto that open spacing where we pushed that HDMI back. And that just lets us know that that joint is fully flowed with solder and that it's connected all the way through. And we're going to go ahead and now clean again. I probably should check the rest of these joints. Yeah, everything else looks good now. And we will do a zoom in on this before we finish. Let's move this back over so that we're not overlapping our video. Move our solder out of the way. My new desk is coming, and when I get this new desk, things are going to be a lot more organized. So hopefully I won't be kind of fumbling and bumbling for my different supplies, because I kind of got stuff thrown on top of itself here. We're not doing anything special with this cleaning. We're just giving it a rub down, trying to take off any of that excess flux that remains. We made sure it was well cleaned before we got started because most of the flux was used in that initial process. I'm going to flip it over and clean the other side. And almost. Get all the gook off if you can. It's best to always remove it at this stage than trying to get it later. And look at that, we had a little solder ball that stuck to that outer edge there. And that's okay, it's not going to cause any harm there, but we do want to pop it off just so that when they go to put in the HDMI, it doesn't cause any obstructions. These are things that people without a microscope probably aren't going to notice, and so they would have a very hard time troubleshooting if it was causing any issues, which it probably would have just broke off on its own. Remember last time we showed that this was severely damaged and now it's one solid joint again, but we are missing this side. We can also clean this area up. Since we're doing a video, I'm demonstrating all of this normally because this is a board for another merchant to deliver. This part of the cleaning would be done by them. All right, remember we talked about this had a bridge, and we wanted to solve that before we sent it back. Again, a very easy thing to fix. We just pull out, we're not even going to need to change tips. Just going to pull out this soldering iron. And you know what, to clean this up even better, we are going to change tips. We're going to go ahead and we're going to pop this bad boy off using a little Metcal silicone grabber, even though this isn't a Metcal. They're all the same. They look identical. And we're going to put back on, we're going to use a different tip just for fun. We are going to use our wave tip, which I really like this tip. This is probably one of my favorites from what Pace has to offer. And we could just use a little bit of flux and do this. But we're going to take it one step further just to be nice. And we're going to even these out. And crank this heat up a little bit again on the tip. You don't want to use pressure on your tips because as they get hot, they get more pliable. If you're having to force them, then something's not right. Now on cheap tips, I'll force the hell out of them. I'll stab, jab, and grab. But although these are not expensive tips, these are quality, and they're not cheap either. They're not $2, $3 tips. They're $10 to $15. So we're going to treat them with the love and care that they demand. And we're going to have to go higher. A 175 is not going to kick it here. So now this wave tip is a much longer tip, so it doesn't retain its heat as well, which is why we had to increase that airflow. But I like the angle on it, and I like the shape. Just makes it a little bit easier to work with, at least in my opinion. Alright, so now that that's been evened out, we can go back and we will tin this tip. Let's go ahead, and I'm going to show you one of the things also I like about the paste is, let's see, see that pocket, that hole? But when you put solder in it, look at what it does. It beads up nice. It'll fill that cavity in, and if we are just dragging over something, which I don't want to drag over on what we just spent all that time working on, let's drag over on this. It's actually, let's do it on this. Very quick to solder that shield. But look at that. It contains a little pocket of solder. It gives you kind of like a reservoir. So for drag soldering, it makes it easier to spread. More tips should employ that. I'm not sure if that's a patent. Other manufacturers do it, but I like it. So that gets a thumbs up from me. Put that in the instant setback, and whew, that's hot. It's hot, hot, hot. That is it. We just need to clean that up, but that is essentially, and I said we would take an up-close look on this guy. Alright, so what we're looking for here is solder bridges, issues that would cause it not to perform correctly, and none of that exists. We do have residual flux down inside of that. That will get cleaned out and should be. But look at our joints here. See how they're nice, they're shiny, they're all the way around. And we got the same thing on the other side. Where'd it go? Right there. Nice, shiny, all the way around from the front to the back and both sides of that through-hole joint. That's what we want to make sure that we maintain a stable connection with these legs. Alright, that's it for how to solder the HDMI and do the swap using the in for the new out port. Again, that one is going to remain missing. If we can put that back into the video right over here, you can see that that will now, at least until someone changes it, will no longer have its port available, but it's going to be used for the main port, and it's as simple as that. If you have any questions, feel free to put them in the comments section below. If you want to see more videos like this, go ahead and hit that subscribe button, and you can, I think I've said before, somebody else has mentioned something about a bell. I know there is a way to get reminders so that you're notified anytime a new live stream is added. That's all I've got for today. We will have more live stream videos throughout the week. Until I see you next, enjoy, and I will stream again soon. Take care, everyone.